So we will continue with concept 11, but we're going to pick off from part B.
Is it going to be a lot?
Okay? I would say you're going to need at least like a page or two of notes. Okay? Are you up? Please remember, guys, these notes are already on headline. You can print them out ahead of time if you'd like to. Again, if you want to print out notes ahead of time, I recommend that if it helps you. Okay. So, last class we talked about two things, domain and range, and we looked at it graphically. Today we're going to look at it algebraically, which just means we're going to be given a function, or we're going to be given an expression, and we have to then determine the value.
Oh, this is the
And so we have f of x, g of x, all that stuff, okay? Now, this is a little bit more tricky than the graph is, the stuff that you have to do here, but once you get it down pat, it's actually quite easy because you do the same thing over and over again. But there are 2 or 3 different things we have to get through today. 2 or 3 main points. One of those main points will be having to do with a radical. Okay, so a square root somewhere. Another main point will have to do with the denominator. And then the third main point is the combination of both of those things. Okay? Now, what I want to do first is think about this. If you were given a function, and let's say, for example, the function was defined as, and this is just a random example, the square root of 2x plus 8. So f of x is defined as the square root of 2x plus 8. Now, before we learned concept 1, we learned about imaginary numbers. What did we say about a radical? What could it not have underneath it? A negative, because you can't take the square root of a negative. Then we introduced the I value, and then from there we were like, okay, now we can do this. Now, the imaginary number I, or the imaginary constant I that we've defined, is not something that we graph. So when it looks like we're about to graph stuff, we can't actually graph if it's a negative under there. So what we want to determine is the fact that there will be x values that if we plug them in, cause the radicand to become negative. And that does not work for us. We cannot have a domain that has a negative under the radical. So, for this example, can somebody tell me a value of x when substituted in that would give me a negative under here? Raise your hand, think about it. Think of a value of x. Think of a value of x when substituted in would make this radicand, the blue box, negative. Okay? Raising your hand, please. Give me an example of one of these values. Anthony? Negative 8. If you plug in negative 8 here, you're going to get negative 16 plus 8 is negative 8. So that works. Give me another example. Negative 3. Negative 3 would make this negative 6. Plus 2 would become positive 2 still, so that one doesn't work. Good to notice though. So we already said that negative 8, if we plug in a value for x, the y value under the radical, we got negative 8 under the radical. Negative 3, we said we got a 2 here. Negative 10. Negative 10 will give me negative 20, and 8 will give me negative 12 under the radical. Okay. What's another value of x? Negative 7. Negative 7 will make that negative 14, and 8 will give us negative 6 here.
Are we trying to find something that's to divide?
Okay, negative 5. The negative 5 will give me... Alright. Give me some values that do work now. Now give me some values of x that if you plug in, you'll get a radicand that's bigger than 0, or it's positive.
Negative 2.
Why negative 2, Manuel? How does that help us? Plug in a negative 2, what do I get? 2 times...
That'd be 4, right?
Yeah.
Negative 4.
Yeah, negative 4.
Plus 8 is... Okay. Now, what's going on here? We're picking random points, aren't we? We don't want to pick random points though in math. It's going to take us forever to do this. So we have to come up with a way to think about how can we find all the values that do work. Okay? And let's talk about this for a second. So a minute ago, we said that we wanted this radicand, okay, if we remember this word, we wanted the radicand to be a positive value, or something that is not negative. Anything that's not negative is positive, or 0 could be also. So how do we say that? How do we say that this value, or this radicand, has to be at least 0 or bigger? Mathematically, how do I write that? How do I write, using mathematical notation, that I want the radicand to be something bigger than 0, or it could be 0 also? Kelly?
You do the radical 2x plus 8 less than or equal, no, greater than or equal to 0.
Very good, Kelly. Again, the statement that was just made was we want the radicand to be positive. We don't want the radicand to be negative. Isn't that what this means? This says the radicand is bigger than or equal to 0. Again, the radicand is bigger than or equal to 0. And that's what we just said we wanted. We want the radicand to be positive. So every time we have a radical, we can take the radicand, set it greater than or equal to 0. And then we can solve this. Okay? So this method works every time, and Kelly just showed us how it works. Now, let's go to our first example. So this was one just to think about. Let's go to our first example. Let's say we have g of x equals square root 3x minus 12. And the question says, find the domain for this function. So find the x values that work. Okay, find the domain or find the x values that work in this function. Based on what Kelly just said, what can I do with this one?
Find it, a negative number.
Okay, but let's use what she said a minute ago.
Do 3x minus 12 is greater than equal to 0.
Very good. Again,
Oh.
this means that we are setting the radicand greater than or equal to 0. Okay, meaning the radicand must be positive. So if you are writing notes down in words, we're saying the radicand must be 0 or positive. Okay, these are the kind of notes you should be writing on your own when I would say so. Because you're not going to write all of this down. But the radicand must be 0 or positive. That's what that statement says. Now, looking at this statement, I can solve this like any other equation. Add the 12 to both sides. 3x is greater than or equal to 12. Divide by 3. X is greater than or equal to 4. Again, treat this like an equation. It is no different than any equation we've looked at. We can graph it, but we're also going to write it in our interval notation that we talked about.
No, we're going to eventually graph it up later on.
Like on a number line?
No, on the grid. Like,
We will graph the original function when we get to concept 48. So we got a little while.
48.
Okay?
Are we going to complete that this year?
We're graphing radicals at like concept 48, yeah.
Are we going to complete it this year?
We got all the way through concept 80 this year. 80 concepts total. Okay? There are
What
80.
concept are we in there?
We'll get there, we'll get there. Now, think for a second. What are all the numbers bigger than or equal to 4? Give me another example. 5, 10, all the way up until what?
Infinity.
Infinity. So I'm going from 4 all the way up until?
Infinity.
So I should write this as domain is 4 all the way up until infinity. Now, who can explain, raising your hand please, why I used a bracket next to the 4? Okay, think about it for a second. Think about it for a second. Why did I use a bracket next to the 4? Andy, give us your suggestion.
Oh, because 4 is still on the chart.
Very good. 4 can be one of our answers, right? It says it's greater than or equal to 4. So 4 is included. 4 is like a closed circle. Again, it's greater than or equal to 4, which means 4 can be an answer. Thus, there's a bracket next to the 4.
What if there wasn't an equal sign?
If there was only a greater than sign, like that right there I'm hovering over,
That would be a
very good, a parentheses. And we'll get to an example like that toward the end. Okay? You can, but I want you to go quick because we're going to start another one in a second here. Okay? Let's look at another example.
That's the window to get that second.
Let's take a look at this one now. There's a trick along the way, so be careful when you're doing this problem. You gotta think back to Algebra 1, sorry. Think back to Algebra 1 when you're looking at this.
Oh, wow.
Start your equation the same way. Whoops, sorry. Y. This should be a Y, I apologize. Start your equation the same way. Okay, and then at that point afterward, though, think about when you're solving this, you gotta do something along the way.
It's a negative number. So,
It would be better if you turned this pretty wide.
Higher.
Look at you, Jay, all trying to be.
Oh, maybe it is. Maybe it is.
Again, remember people, X, Y, Z, A, B, D, does not matter what the variables are. Here, we've got a function h of y. Y is now your domain in this case. Again, remember, the domain is simply the independent variable. So earlier we had this as an x in here, right? Now it's a y in here. So now we're looking at y for the domain. It does not matter. It does not matter. It's your horizontal axis that has the domain. Here, subtract 18, right? Now what should I do? Divide by negative 3, right? What else? Very good. When you divide by a negative with inequalities, you have to flip the inequality sign around. That is the trick, again. So here, when I divide by negative 3 and divide by negative 3, whenever you divide by a negative, you have to flip the sign. So that will switch now.
so it's going to be less than.
Okay? Be careful there. The sign switches when you divide by a negative. Okay, when you divide by a negative.
Don't two negative number makes a positive?
They do make a positive.
Oh,
So y must be less than or equal to positive 6.
But this is only for that part, that part.
Again, this is only for inequalities. Only inequalities. So for the domain, what is less than negative? What is less than 6? 5, 4, 3, 2, 1, 0. What about all those negative numbers?
Negative.
So it goes right down to where?
Negative infinity.
So for the domain for this one, we have to write it as follows. Again, this time, be careful. We are not getting bigger with our number like last time. Everything was greater than. Now it's less than. Anything less than 6 means we are really going from 6 all the way down to negative infinity. But we write it in the correct order. We go from smaller to larger, and that's our standard notation. Just as a side note, if you're looking at words, this is called set notation. This is called interval notation. They represent the same thing in this case.
You say what?
Okay, again, this is called set notation if you leave it like that. If you make it look like this, the way we've been using it's called interval notation. I use interval notation a lot because it is easier to see. You know, you're going from negative infinity to 6. Now, set notation you will use as well. So it is good to know how to interchange between the two.
if it's like negative infinity and like let's say 1,000, it would still be close, but
If it's going to 1,000, you're asking?
no, if it's like somehow 1,000, right?
So instead of a 6, it's 1,000.
1,000, it's gonna be a close parenthesis.
It all depends on the symbol here. See how this is less than or equal to 6?
Yeah.
That's what indicates the bracket. If it was just less than 6, it would be parentheses. Because that means that if it's just less than 6, 6 is not included in the answer. Thus you put a parentheses. Since 6 is included in the answer, you put a bracket. Okay, next one.
No. You get it with it?
Guys, don't forget this record. You can look at the video later if you missed anything.
I have like 2 letters.
That sounds beautiful.
You can't see your face, you go to the
Obviously.
It's okay.
What?
Nothing.
Okay, let's look at the second case now. We talked about radicals. We said we can't have a negative under the radical. What can I not have in the denominator?
A negative.
No,
No.
They
They have a radical. They don't have a radical. Very a variable.
You all fell into the trick. What can you not have in the denominator? What can't you divide by?
It's like
A zero.
A zero.
Oh.
So think about it. If I made the denominator, if I made x4, wouldn't the denominator be 16 minus 16?
Yeah.
Think about it.
would
Put a
be
4
zero,
there.
so
it can't be a 4, right?
So it has to be greater
So it
than.
has to be greater than.
But it could also be less than 4, because that would make a negative. We could have a negative.
So what would be exclusive? I mean, not exclusive.
Excluded.
Oh, excluded.
You're right. That's exactly right, Kelly. 4 does not count as part of our answer. How do we do this every time without having to pick a number? Let's take a look. We say the denominator cannot equal 0. Whatever the denominator is, you set that not equal to 0. Again, whatever the denominator is, to find our exclusion here, we set it not equal to 0. And there's some.
4 cannot equal to 0.
No. Continue to solve.
Plus 16.
Karen, continue to solve.
Video's one of the. That's how video.
Eddie.
Okay? Be careful. You said 4 cannot equal 0.
Oh, I said it wrong.
I understand what you meant. Be careful though when you say things, okay? So x cannot equal 4. Again, x cannot equal 4. Okay.
Oh. Stop.
Now,
They were that little apple.
focus guys, focus.
Gratitude.
I want to write this in interval notation. This is difficult to do. Again, I want to write it in my interval notation. This is still just set notation. If a number can't be 4 and it can be everything else, can somebody think about a way that we can write that using interval notation?
It can't be 4.
It cannot be 4, as we can see, but it can be anything else.
Oh, it's like a the not equal sign on one side and the other sign be
Wouldn't it be an inequality?
In interval notation.
oh, sorry.
That's all right, but think about interval, Anthony. We want to go from where to where and where to where.
Wouldn't it be like negative infinity and then like more than 4 and then less than infinity?
Close. You're close.
X equals 4.
You gotta put it for.
I want to think about it this way, guys. We're taking every number from negative infinity all the way to 4. We're excluding 4, and then we're taking everything from 4 to infinity.
So could it be negative infinity and then infinity
Oh.
and then not equal to 4?
You could think of it that way, sure.
I got one.
You could think of it that way.
I can have negative infinity and 4 and then parentheses and and yeah the u and then but 5 or 4 and infinity.
Very good, sir. Very good.
Okay, I see you.
Take a look at this one. Very good. This means we're going from negative infinity all the way to 4. We are not including 4, hence the parentheses. Then we're picking up again from 4, still not including 4, going all the way to infinity. So this shows that it means all numbers except for 4. That's what the parentheses means on 4. Okay? So it's like negative infinity all the way to 3.9999999, and then from 4.00001 all the way to infinity. So it's like you're getting to 4, but you're not actually including it in your answer. Okay? Eddie.
So when does 3x come in?
It doesn't.
Very good question. Does 3x play any role here?
No.
Because the numerator can be anything. There's no restriction of what our numerator can be. Unless the numerator had a radical, and then we have the next situation. But for now, it doesn't do anything. Good question again.
So why is it a parentheses in front and behind of infinities and not a bracket? Because we don't. Oh yeah, because I just remembered. Okay.
All right. Again, you can't get to infinity, right? Next one.
Oh wait.
This the one you giving us, so we do it? Take the example.
Here's another one example. Yes, I want you to work on this one. Now, look at your denominator here and be careful. Now take a look at your denominator. It's no longer linear, it's now quadratic. Think about how to find the values of a in the denominator. Again, your first step is the same as last time. I'm not going to show you the work, but just set the denominator not equal to 0. This is a note you want to write in your margin. You set the denominator not equal to 0. Because the denominator cannot be 0. Okay, the denominator cannot be 0 by any means.
What is that?
Now the goal is just to say, okay, how do we find A? Who remembers, forget if it's not equal to 0, make believe it were equal to 0. What can I factor this into?
You have to put like
A
A
plus
times
A plus
Oh.
A plus 3
A plus 3 and A
Wow.
Karen's fastest on this one. Again, what numbers multiply to give me 3 and add up to 4? Those numbers go in those spots. Now, we've got a T-chart here set up we can do. Again, it's the same as last time. Last time we had a 0 there and it was equal to 0. Now it's not equal to 0. Make your T-chart the same way. So continuing this line, we say A plus 3 does not equal 0. A plus 1 cannot equal 0. Thus, A cannot equal negative 3, and A cannot equal negative 1. So in this case, instead of having one exclusion like the number 4 last time, now we have 2 exclusions. Why do we have 2 exclusions? Because our denominator was squared. Quadratic means there are 2 solutions. So 2 things will cause this not to work. And go back and try it if you don't believe it. Take a negative 3, plug it in. It will not work. You will get a 0. Take a negative 1, plug it in the denominator. You will get a 0. We can't have 0. So these are our exclusions to our domain. Now, if I want to write this domain in interval notation, this one's going to get a little messier. Okay? Let's think about this for a second. For my domain, if I want to write this in the correct notation, I always start where? Okay? Now, in this case, what's the first thing I have to stop at? Because negative 3 comes before negative 1, right? Think left to right. As you're starting from negative infinity and you're continuing to move from left to right, you're going to hit negative 3 first. So this goes to negative 3, and negative 3 is not included. Then it picks up again at negative 3.
to negative 1.
Very good. It goes from negative 3 all the way to negative 1, but we got to stop there. And then it picks up from where?
Infinity.
All the way to infinity. Yes. We're going to do the next one. It's a little tougher here. So again, the domain is going from negative infinity. It's going all the way to negative 3. But at negative 3, there's a problem. You can't have it there. So we show that by saying parentheses on both spots. Then there's a problem again at negative 1. And we go from negative 1 all the way to infinity. Okay? Some of you have seen using a number line before. If you were to represent this on a number line, we would have shade all this in, open circle, shade all this in, open circle, shade all this in. And this means that all the numbers in the domain except for negative 3 and negative 1. Okay? And some of you have seen this before, and that's good, because we will use this, and you will use this in pre-calculus as well. Okay? Let's go to another example that combines radicals and denominators at the same time. Okay, we're going to do 2 of these. What number are we on? Anybody got numbers?
5.
5? Thank you. So this is going to be a radical in the denominator. A radical in the denominator. So here we have, let's say, m of b equals 2b over b 4b plus 12.
You have a negative radical.
Okay, again, the radical can't be a negative.
Or you can have a 0.
And we can't have a 0 in the denominator.
So you can exclude 0.
Very good. So, normally, wouldn't I do this? Wouldn't I normally do that for the radical?
Yeah, but it's a denominator.
So, in the denominator, we can't have what again?
0.
So I have to go back and say, erase that less than or equal to, or greater than or equal to, just make it greater than. Again, normally with a radical, it's got to be positive. So we say greater than or equal to 0. But we can't have a 0 anymore because now we're in the denominator. So we simply say greater than 0. So if you're writing down a note here, when a radical is in the denominator, it is simply greater than 0. Again, where does that come from? It's usually greater than or equal to 0, but you can't have it equal to 0 because it's in the denominator this time.
So, does the numerator, does it matter?
Does it matter here?
Yeah.
You answer your own question. Does it matter?
I'm asking. No.
Pick a number for me.
No, I'm saying it doesn't matter when we're solving.
In this case, it does not. If you had a radical in the numerator, then it would matter, and we'll do that next.
Are you finding that?
Yeah.
Okay? Again, you don't have to flip the sign this time because you're not dividing or multiplying by a negative. Very good. Again, you do not have to flip the sign of the inequality because you're not dividing or multiplying by a negative value. If you were dividing by, say, -4 instead of 4, then you would have to. Final answer in interval notation. If it's greater than -3, it means I'm going from -3 all the way to?
Those students leaving for the 3:15 field trip, please report to the office immediately.
I'm assuming.
Please report to
Is
the
it
front
ready?
office.
Okay.
Whether you're on
Where are you going?
front office, please, for field trip.
Anthony, catch the end of the video online. We'll do one more example.
Yeah, man.
Right?
Same
So you have the homework sheet already. It's back on page concept 11, those last problems on the homework sheet.
Let me find the range.
Until 8 o'clock.
For these ones, we are not even doing the range right now. All we're looking at is restricted domain here. Okay?
Okay.
All right, let's go to the next one.
How,
Yes.
how is it a parentheses -3 for the?
Why did I put a parentheses this time? Can it be equal to -3?
No.
No.
It's only greater than -3 this time, right?
So.
See, remember last time we had an equal to sign down here? That equal to sign meant the -3 was included in the answer. But this time, it's only stuff bigger than -3. So -3 is not included in the answer. When it's not included, you use a parentheses. So again, you can think of it this way. A greater than or a less than sign means a parentheses. It doesn't matter which sign, depending on where you are. A greater than or equal to or a less than or equal to indicates you're using brackets.
I don't think you remember that.
see it.
Cause like, what they taught us was that like, when there's a line underneath it, like the bracket has a straight line.
Oh, you can do it that way too. See how she sees the horizontal line here? And in the bracket you have lines. Whereas here there's no line and these are just curves. Works for me. Anything that helps you. Again, these are things that I always did too. Find some sort of trigger that helps you in your mind assess your long-term memory, right?
Yeah, just-
So you want to see something and say, oh, I remember that because of this, or because of this. So you make connections to things that help you. Just like on a computer, right? When you're looking for a file on your computer, you don't just search randomly, you search a folder, then you search a subfolder, and then you're looking at another folder. So if you ever see me going through my notes, when I open my notes here, you'll see I have DVCR, then I have the year it's in, then I have the class that I'm in, then I have whether it's my notes or homework, so I have a lot of subfolders. That's what you have to do in your brain. Okay, when you're doing this kind of stuff, give yourself some sort of a trigger that helps you remember things. Okay, let's look at another one. We are number 6 now. Let's look at one where we have a radical in the numerator, and we have a denominator that causes an issue, both.
Oh my gosh. Oh my
So we'll
gosh.
say v of x equals
What are you writing on my paper?
square root of 2x minus 6 all over 3x plus 12. Now, please keep in mind that we did this 2 different ways. You got a radical, that's one scenario completely separate from the denominator. So think about your radical, what you have to do there, and think about your denominator.
I thought
If
we
it,
didn't have to worry about the numerator.
well, now we do because we have a radical. And no matter what, if there's a radical anywhere, you always have to worry about it.
So the radical would be the range.
Not the range, but we have 2 types of restrictions to our domain here. We have a restriction that is based solely on this radical, and we have a restriction that is based on the fact that we have a denominator. So we need to do them separately here. So based on the radical, what should I make a statement of?
So x minus 6 equals
Yeah.
greater or less than 0.
Greater than or equal to this time, right? It's not in the denominator anymore. Again, the radical is not in the denominator, so it's still greater than or equal to. It's still greater than or equal to. Now, on the right-hand side, I still want to think about my denominator. What can my denominator not be?
0.
zero.
Denominator cannot be 0. Very good. So we say 3x plus 12 cannot equal 0. If you are thinking about this in your mind, you need to make association between the words you're saying and the symbols.
Oh, I have a question.
The radical must be greater than or equal to 0. That's the left side. The denominator cannot be 0. That's the right side. So you have to be able to tell me what is going on here, not just write down the equations. You need to make the association that is going on, or looking at the function and looking at the restrictions.
If there was a radical in the denominator, it would have been 3x plus 12 is greater or equal to 0? Or
Just
would-
greater than, remember, because it can't be 0 in the denominator.
Oh, okay.
Okay?
What?
Solve these separately. Solve them separately. Solve one of them and then solve the other.
X equals 3.
Be careful.
Negative 3.
No, you're still right, but be careful with your words.
Oh, greater than equal to 3.
Very good, Karen.
My God. Pick that up right now. I don't know who did that. Pick that up.
Take a look at your answers, check the board, make sure it makes sense.
X cannot equal 4.
Negative.
Yeah, I remember
Why is
doing
it
it. y'all.
Check your work.
Oh,
Now, I'm going to extend this page. We're going to write a little more here.
Raymond?
You need to think logically at this point. At this point in time, you have to use your actual mind here to think about what's going on. It's not easy. Look at what's going on here. Everything has to be greater than or equal to 3, right? What about negative 4? Is that greater than or equal to 3?
Included. But then 3 is included.
It's less than 3.
So does it even matter?
No.
Again, think logically for a second. If we were to write the interval notation for the domain here, we would say that this goes from 3 all the way to infinity. That's the left side. Would you agree with that?
Yeah.
Again, we're going from 3 to infinity. Is negative 4 inside of 3 and infinity? So do I even care about that this time? Again, this restriction actually does not have any role. This one right here does not matter, because the first restriction tells us that it can only be greater than or equal to 3. Well, negative 4 is not greater than or equal to 3, so this one kind of covers that one already. Again, this one is like saying the same thing already. Let's say, for example, you go to an amusement park, and the ride says you cannot be taller than 6 feet, and you cannot be more than 200 pounds. If you, sorry, man. If you happen to be both, it doesn't matter which one is which. If you're already bigger than 6 feet, you can't go on the ride, right? If you're bigger than 200, you can't go on the ride. So it doesn't matter if you're both of them. It's just one or the other.
Yeah.
Here, both of these actually don't matter in this case. In this case. Again, only in this case here. So at this point, you have to use logic to see what your answer really is. Let's do one last one that will alter this a tiny bit. I want to show you one more example.
So domain is not 3, negative 4?
The domain is not 3. The domain says everything bigger than or equal to 3. That's this right here. Is negative 4 bigger than or equal to 3?
No.
It's not. So I didn't have to list it, because these already get rid of that. Think about everything that's between 3 and infinity. That's not even there. So this doesn't even matter in this case. You have to do it, though, because sometimes it will matter, and we'll look at an example right now where it does matter. Let's try number 7. Let's say w of x equals square root of 3x plus 15 and 2x minus 8. Did you use 2x minus 8 last time? No, right?
You 3x
No.
plus 12.
Okay. Thank you, sir.
Yes, you did.
You got the same answer, but you didn't. You're still going to get a 4. Again, split this up into two scenarios. The 3x plus 15 must be bigger than or equal to 0. The denominator cannot equal 0. Again, in your mind, you need to be able to say what's going on. The radical has to be 0 or positive. That's the left-hand side. The right-hand side, the denominator can't be 0. And then just solve it. This one you will get 2 answers, and be careful when you get them.
Is negative
questions when you get through them, please. If you got a mistake, take a look, see where it was. We're almost done, guys. Give me one more minute. Now, at this point in time, even if you're not done, just take a look up. I can give you a second at the end to look at the board. If we think about this, everything bigger than or equal to negative 5
May I have your attention, please?
means that, right?
Yeah.
But isn't 4 bigger than negative 5?
Yeah.
So we can't have 4 in this
Please listen to
time.
these announcements.
So this is not our answer, but really we go again from negative 5.
What?
This should have been a bracket, sorry guys.
The following students should come to the office at dismissal: Veronica Carrillo, Juan Johnson, Leonie Enriquez, Cesar Benitez.
Again, we go from negative
Laura
5
Louis.
all the way to 4, but when we get to 4, 4 is not included.
At dismissal.
So we put our parentheses, we pick up again at 4,
Students who need to
and go all the way to
meet with an
infinity.
error after school should come to the library.
So how is 4 not included?
Again, this shows that 4 is not included, because it goes up to 4, parentheses, not including 4, starts at 4, not including 4, parentheses, all the way to infinity.
The following students.
4 is not included because of this statement
Office
here.
at dismissal.
I'm going to pause for a sec, we'll continue talking if we need to.
Three rainbows. Darren Portita,